Okay, I paused the video a little bit there because I was a little bit confused as to why, whenever I pressed a full stop there, I didn't get all of the methods and all of the variables of human being and of student together, because I inherited my HS student inherits from student, which inherits from human being. So I should get all of the public methods. I wonder if you can spot the mistake with me. I just clicked across to the definition of HS student. Can you see what the problem is? I was a bit blind and I didn't see the red X there, and I've spelt extends wrong. as I was speaking, I said extend. So if I change that to extends, it changes color, the class compiles, and if I go back to my tester program, I'll see that I have absolutely everything from human being and from student, and anything that I'd added in HS student would have been there as well. So there you go. What I've done is I've added another level in here, and this one he's defined as an HS student, but I could define him as a student, and then he would get slightly fewer things if he wouldn't get the HS specific things, or I could define him as human being, and then all he would get is the basic human being stuff and no classes or anything like that. Okay. Now, what I can't define him as is I can't define him as a teacher. That's not going to work. Or is it? Oh, yeah, it is. Sorry, it is going to work. It is going to work because he supports a subset of the same things that he inherits from the same base class, the same superclass as teacher does. So therefore, those things are still available, even if I define him as a teacher. I'd like you to think of this as a mask. Now, sometimes I kind of do a little exercise where I get people to fold bits of paper, and if you think of this as, let's just find a bit of space here. Imagine I have a piece of paper like this, okay, and I put holes here, 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 and here, okay. Now, get my toolbar back. Where are you? Toolbar? Where have you gone? Don't know this program very well. Okay, I would quite like to be able to copy and paste that. Can I have that, please? Toolbar, Windows. It'd be really nice if I could do this. Toolbox. Expect it to be. There we go. Okay. Right, so I'm going to take that. Oi. I'm going to select this and paste it. And for some reason it's appeared down there. That's great. Okay, let's just do this. Okay, imagine I have two pieces of paper which look exactly the same, but they have 4 holes in them. And those holes, if I put the 2 bits of paper on top of each other, you would see 4 holes through that, wouldn't you? Now imagine if I add another, and where's my toolbar go? All right. Okay, come on. Give me my toolbar back. Where are we? Toolbox, please. Excellent. Thank you. Right. Imagine for a second that I add another hole in here. Now, what I can see is I can see my finger poking through here, poking through here, poking through here, poking through here. But I can't see this one because there are 2 layers of paper, and my finger's gone through the first one, and it's obviously stopped here because there's no hole here. All right, so what I'm trying to say with this is that if I'm declaring something, let's get my toolbox back, thank you very much. If I'm declaring something, let's get rid of all that, and I say, let's have human being HB equals new student. Okay, so in this case, I'm just going to put that on there. In this case, the human being is equivalent to, come back. The human being is equivalent to this, and the student is equivalent to this. Now what I'm saying is that the student has a superset of its own features and 4 equal features that human being has, these 4 to be precise. So if I define it as a human being, if I define that variable, declare it, sorry, as being a human being, but I store a student in it, it's like this mask that I'm using to see my variable from. This is my eye here, okay? This will all make sense in a second, maybe. Okay, that's my eye, all right? Might not look like much of an eye, but it's an eye. There you go. I'm looking. This mask that I'm using is what it is declared as. And the object that I'm seeing through the mask, even though it's a student, that object, I cannot see through it. I can't see it as a student because the mask that I'm looking at it through is a human being, and a human being only has these 4 holes. It doesn't have the 5th hole in the center, so I can't see or use that 5th hole. Now, can I jump back to code again? Because I've defined this as a teacher, I'll go back a step. Because I've defined this as a human being, even though it is a student, it's got the 5 holes and lots of extra stuff in there, I can only see the things it has in common with human being. Likewise, even if I make this it doesn't matter if I make this a student or a human being, I still can only access those things. However, in the background, it's more than a human being. If I make it more than a human being, if I make this an HS student, this will be a high school student, but I'm only looking at it through the mask of a human being. That's called the type that it's declared as, and this is the type of the object. The object is an instance of HS student, but it's declared as a human being, so I'm only able to see its human being properties. Now there is a way that I can change that back into an HS student, and I think I talked before briefly about why we might want to do this, why we might want to generalize, because we can pass parameters into a method without really knowing which subclass they are. But let's run with this for a second and see if I can remember how to do this, because it's been a while. So if I want to change this student, which in this instance of the class student, back into a HS student so I can use it, I would need to make a variable of type HS student, and I'd have to make that equal to, and then I would have to cast it into an HS student and cast the variable HS into an HS student. Now, is that correct? HS student. Oh, I need to give it a name. HS student, this time it works. I'm going to be optimistic. HS student, this time it works, equals, and I've taken the original variable, which is of the contents of the original variable, and I'm casting it or forcing it to become an HS student, which in actual fact what that's doing is it's just making, it's just taking these, whatever this is here, these 5 functions or 5 holes, and it's, instead of looking at it through the mask, a limited mask of it being a human being, it's looking at it through the mask of an HS student. Okay, I hope you understand that. If you don't, this will become more natural over time. And I want to summarize, before I move on to polymorphism, I just want to summarize quickly that inheritance is when you have a superclass with a lot of public methods, i.e. behavior, and variables, i.e. state, and you extend that superclass, so you inherit those things down, and even though your subclass, the one below, doesn't have all of those things, it does have them because it inherits them. And Also, you can have multiple levels of inheritance. You can have an HS student, which inherits, which extends a student. The student extends a human being. But what you can't have is you can't extend more than one class. So I can't say, for example, something extends student and, teacher or something like that, because Java only allows single inheritance. So I can only extend one class. Some other languages allow multiple inheritance. For example, C++, and believe me, having worked with the two languages, C++ projects are very, very, very hard to debug when they get big, because the diagrams that you can possibly draw couldn't cater for the total number of possibilities and where public methods are coming from and which one has more importance and stuff like that. So Java is very safe, handles this very neatly, and that's inheritance.